Hi and welcome everyone to this edition of the Keptn user group. Today we already have a couple of folks joining and I'm very honored and pleased that we also have a great presentation from Adrian coming up. I've already seen parts of it. I really love the use case and how Adrian solved actually the challenge of evaluating the application resiliency with a couple of different tools. He brought everything together and he will be explaining the challenge and also the solution to us in the bigger part of this Keptn user group for today. The Keptn user group is also following the CNCF code of conduct. That basically means please be nice to each other, please respect each other. If there are any questions, please put the questions in the chat, and after the presentation of Adrian, I will also open up all the microphones, or I allow you to unmute yourself so we can have a discussion, and please feel free to ask all the questions directly to Adrian, or also questions around Keptn, the Keptn project in general, some use cases you're interested in. Please feel free to share your questions, your thoughts, and give feedback. I will again put in the link to this document that I'm sharing right now in the chat. So please feel free to also add your name in here so we can keep track a little bit of all our attendees in these sessions. Just writing your name and your affiliation, that would be great. Actually, Michael is also joining. Hi, Michi. He's from Gitlab, so I'm really curious also to hear your thoughts on this, what Adrian is presenting. That's great. Yeah, with this, thanks everyone for joining. Please also put this on your calendar. We are doing this kind of meetings every third Tuesday of the month. And as you already know from the first edition of the Keptn user group, it's more focused on Keptn users, how users are actually taking advantage of Keptn, what are the main use cases they want to implement. And therefore, it's not so much focused on the Keptn developers. The Keptn developer meetings, we still do them on Thursdays, same time as Keptn user groups, but we just have these two different kinds of meetings. So with this, I think I'm already handing over to Adrian. I know that you have a short introduction for yourself in your slides, so I will just give away the stage to you. Adrian agreed that he will also share the slides afterwards, so we will put the slides in here, and we will also put, once the recording's up live on YouTube, we will also put the recording link in here. So thanks already for putting in your names, and I will be handing over now to Adrian. And really
Thank you very much.
Forward to your.
Okay, so just let me know that you can hear me, that you can see my screen.
All good, we can see your screen. And again, if you have any questions, please put it in the chat or in the Q&A, and I will be either throwing them in to Adrian or we will just discuss it afterwards, after the presentation.
Perfect. Thank you very much, Jurgen. First of all, thank you for having me here. Thank you for your continuous support, Jurgen and Andy and everyone at Keptn and Dynatrace. That's really a blessing to have such support when you take a difficult task you have no idea about. Basically, this is the first story and the first chapter of the journey. I had no idea where it's gonna when it's gonna lead me. And how it's gonna go on the way, but hopefully I was able to reach the first milestone. And first of all, when you listen to my presentation, don't treat it as any kind of expert's story or huge expertise on this kind of implementation, because for me personally, this is the first try of this kind of chaos engineering and resiliency testing. It was a hard but joyful time, so please be aware that this is nowhere near perfection. This is just the first proof of concept, and hopefully a great start to something really important for us. So I will tell you a bit of a story, but first let me turn on my timer so I don't talk whole day. Okay. So I would like to show you today, guys, and also this is a challenge because I don't really like online meetups, but we are in these difficult times where we cannot meet each other and have a beer and talk about this. So let me tell a short story about the idea, about the way that led us to some prototype and where we are now and where we want to go with the idea of evaluating application resiliency, or basically implementing some kind of site reliability engineering in Kitop. But first, 2 words about me. Every day I don't work in Kitop. I'm a site reliability engineer in a company called IQVIA, but as my additional task and my consultant's role, I cooperate with Kitop. I will tell you 2 words about Kitop in a second, but first let me tell you about myself. So as I said, I have some experience in the field of QA, quality assurance, software testing, and also a bit of site reliability engineering lately. I work in IT area since 2013, so around 8 years so far. I've been a tester, test lead, software testing manager. Also, as I said, now I'm a bit more on a SRE side, and who knows where I'm gonna go. I'm obsessed, absolutely obsessed with Python. I never fell in love with Java, but when I learned Python, it totally got me. So most of the things I write with Python, whether it's test automation or support code or some SDKs, etc., etc. I'm also quite obsessed about Kubernetes and cloud. Actually, that's quite funny because when I was working in a company called Impost, part of this engineers are now working in Kitop. That was the first time when I heard about Kubernetes, and I'm lucky enough to meet those people who basically taught me about Kubernetes, like Sebastian in Kitop and Marcin. Now we are back on the same track for another journey. And I'm also teaching people, mostly in area related to software testing. I teach at universities in postgraduate studies. I also do some trainings. And most of all, I'm quite focused on automating stuff. Not only test automation, but basically how to automate different stuff. We have some guests from GitLab, so I tell you that lots of my problems are solved using GitLab pipelines. I really like what you do there and how these things improve my everyday life. But using automation in GitLab, Python, using some tools, I'm able to maybe make mine and some of my coworkers' life easier. And Kitop is a company that is not from Poland. It's from I don't want to lie. So let's just say this is a company that delivers kitchen as a service. So basically it serves as a kind of software platform where you can put your restaurant, where you can put your shop, and which serves as a meeting point between people ordering some food, etc., and restaurants and companies that deliver food, mostly in Middle East, but I'm quite sure that they have much more to come. So basically, we are dealing with quite a big traffic related to putting orders to the system, processing those orders, and serving them to different kind of entities, such like kitchens, restaurants, etc., etc. And that's where the idea started. So once we met for a quick coffee with guys in Kitop, I think a few months ago, I think it was November or something like this. And we had this idea, or they had this idea, which was sparkled by, this sentence. So we had this little production issue, and that's how it all starts, always. So now, as an action point from this little production issue, they said that they would like to, or we would like to test our resiliency, improve the resiliency of our system. So we need to find a way to test it. So we thought that it could be done in a modern but quite natural way. And for, I think for many cloud living platforms, the natural way today means chaos testing. If you are not familiar with the idea of chaos testing, let's just say that this is the kind of engineering that is supposed to introduce some kind of malicious behavior to your system. And malicious behavior maybe not be the best word, some kind of unexpected behavior, such as network problems, maybe problems with some other services you depend on, basically introducing some kind of chaos. So this is simulating a real situation, more or less, as you would sometimes face on production. Sometimes one of your service is not available. Sometimes you have problem with connection to database. Sometimes maybe you have problems with restarting your application, etc., etc. And for some time, chaos testing has been around, but I have never been able to put my hands on it. And this time we decided maybe it's going to be a good way to choose for our testing. So maybe we would like to introduce the unpredictable factor by using chaos testing. But on the other hand, we would like to deal or simulate the production like traffic. And for me as a QA engineer, and maybe for some of you, the natural way or the intuitive way of simulating production like traffic is load testing. So this is also what we call non-functional testing, and is maybe most of you will be familiar with JMeter, maybe Gatling. Some of you may be familiar with Locust I'm using, but basically on the other hand, on the client side or on the production side, we have some load generated via some tool. So the initial idea was very simple. Let's generate some load. Let's introduce some kind of chaos to our system, and let's see what happens. Let's see if we are able to survive this kind of natural state of bigger or smaller disaster. And first we sat down and we thought, okay, so what building blocks would we need for this idea? Because of course, we have the very rough idea, but we need to put some necessary tools. And basically at the very first meeting, we established a set of building blocks, building tools we would need to achieve this goal. So the list pretty much went like this. We need a source of traffic. So we need to generate or stimulate our system the way our users would do. And then since we have the traffic and since we have working system, then we will need some kind of chaos generation. At this point, I'm talking about broad abstractions. So since we have traffic, we also want to introduce some chaos. Thus, we need some kind of chaos generator. Also, a lot of applications are storing metrics. So in order to see how our system behaves, how we can track the behavior of our system, and also how we perform in terms of traffic, how we perform in terms of chaos retrieval, we would like to store those metrics somewhere. And possibly after this testing, we would like to draw some graphs, see if we can narrow down our bottlenecks, and if we can see what was happening basically to the system afterwards. And then we need some sort of evaluation. So we did some job, we generated traffic, we generated chaos. We are able to draw everything that was happening to the system, but are we able to evaluate what if the test was green or red, if the behavior was positive or unexpected? And last but not least, we need some kind of runner. We need some kind of tool that will lead the orchestration here. So going step by step, the source of traffic, for me, the natural thing, and luckily for the team, for the QA team there, which also are some of my friends, so I'm very happy to have my friends everywhere. We decided to go with Locust, which is very easy Python-based load testing tool, very similar to JMeter or Gatling. So for our purposes, you can think of Locust as basically the load testing, performance testing tool, pretty much the same as JMeter in a black box view. Then for the chaos engine, the suggested solution by our DevOps team was Litmus. After some research, they suggested and they implemented very first version of chaos engine using Litmus. And after some time, I learned that also Litmus is the tool that Keptn team is cooperating with. So that was a very natural and good choice. For metrics and graphs, I think most of you know Prometheus as a source of metrics and Grafana as the graphing engine. This is a very popular stack, so I think most of you should be familiar with that. And for results evaluation, I said, okay, so we will run this test and I will find a way to script the evaluation. I will just basically pull some metrics, put them together, see what was the failure rate, what was the request per second. I will do it. I mean, it should not be easy. I will just script it probably. So I will use Python. And for a runner, as nearly most of our projects, we use Gitlab, which would be basically the orchestrating platform in this matters. So we went for a beautiful prototype. I hope your prototypes are better, but first idea was like this. We thought about it at the very first meeting, and we thought about the idea of 3 stages of chaos. And by 3 stages of chaos, I don't mean the 3 lockdowns or how many lockdowns you had in 2020. It was a bit less heavy. And the 3 stages we basically imagined. And once again, don't treat it as some super expert knowledge in chaos engineering. Treat it as my attitude or our attitude, the idea we had, and maybe some inspiration. If you have any comments, then go ahead. But the initial idea and the idea we still have now were defined by 3 stages. The first stage would be no chaos. So basically, we would like to see how our system performs, or what are the results of our load tests. And by the metrics from load tests, you can probably think about requests per second, or maybe what is the error rate for particular endpoint. So these are important metrics. So we'd like to basically have a baseline. So we'd like to run our performance test without any chaos for some given period of time and treat it as our baseline. And then we would like to introduce some light chaos. And now, what does it mean, the light chaos? As a light chaos, I imagine imagine that you have a perfect environment, no one is using, freshly configured, etc., or maybe your stage environment at night, basically very peaceful place. This is no chaos stage, where we don't have any unpredictability, when we don't have any natural movement of a system. And light chaos should introduce some kind of natural randomization to the system. So it should not be a failure of the system, but it should let us implement some kind of small issues. So for example, as I taught Jurgen today, you can imagine that using AWS in the morning, and when the USA wakes up and you are using the AWS at the same time as the guys from USA, you see that the response times of AWS are different. So for example, if you are able to do something within seconds or minutes in the morning, it can take 15 minutes, half an hour in the evening. Also, when you have some kind of natural delay between applications and database, you have this kind of unpredictability, this randomization, where you don't really know if you're gonna connect within 50 milliseconds, 500 milliseconds, or 5 seconds maybe. This is the light chaos. This is not a bad behavior, but this is some kind of natural randomization. And our expectance for the state of no chaos and light chaos for our applications is for the users to be the same. Maybe we will have a slightly less true output, slightly less request per second, but we should not observe any errors. So whether we have the perfect state of no chaos or very gentle or light chaos, natural production conditions, we should not observe errors and we should not observe any drop in our performance. On the other hand, we have heavy chaos. So we introduced this concept of heavy chaos, which is the bad behavior. Something bad goes on the, like something goes really wrong. Maybe we have a really bad network latency. Maybe our database has dropped. Maybe we cannot connect between pods. And then of course we will observe failures. But at the same time, we should be able to recover from those failures pretty quickly. So this is the very important idea for the development of the whole project or the whole concept. So just keep in mind that no chaos and light chaos for you as an end user, for example, people ordering at restaurant or people using the app in the kitchen, should be the same. You should not observe any drop in performance. But on the other side, during heavy chaos, you can observe these failures, but for a short period of time, and then we should naturally recover. So these are our conditions. And these conditions were translated into Litmus scenarios as this. Light chaos for us for now as a proof of concept is a network packet drop, so introducing some latency, some unpredictability in the network. For light chaos, around 25%. Light enough not to destroy our system, but to introduce some kind of randomization. And on the other hand, for heavy chaos, we selected quite significant packet drop of 75%. That would definitely cause problems, but we should be able to recover. And for the tests and metrics, we've chosen Locust, and as an addition to Locust, so-called Locust exporter. So we built our architecture of Locust in a very easy and natural way for Locust. So we have one master node that orchestrates workers, and the workers are realizing the requests. This is done in order to be able to scale up. So whether we want to run 10 users, 100 users, 1,000 users, or 10,000 users, we are easily able to scale our workers. And the master node is used only to communicate with the exporter. And exporter is the layer between Locust, or the test results, and Prometheus. So our test results are stored as a metric in Prometheus, basically. And then we put together, I put together a very simple GitLab pipeline, which we could summarize, in which I would store the artifacts from tests. So my test results would be basically in the first iteration stored as files containing the results of tests. And the pipeline looked pretty much like this. I would run some load tests without introducing any chaos, and I would store the results as the GitLab artifacts. Then I would run the same load tests, but I would introduce the light chaos. Also, I would store the artifacts, GitLab artifacts. And then as the last round, I would run the load tests, but I will introduce heavy chaos. At the very end of my pipeline, I would like to run some script, and I run some script to evaluate the metrics. And I had the result, whether my pipeline was as expected or not. That wasn't that bad, but there is a better solution. Or after giving some thought, I was able to find a bit better solution. I thought to myself, wait a second. A few years ago, I met in Krakow, I met Andy from Dynatrace and Keptn, and he was telling us the story about Keptn, very early stages of Keptn. I think it was around 3 years ago. Then he came again. Then he told us the story again, a bit more cheerful story, but still, I didn't even move a finger. But now, a few years later, there comes the time when I think to myself, hey, it's time to use this Keptn to see how it goes. I only remember that there was something as Pythometer, which was, I think, replaced with some other applications, but nevertheless, I synced up with guys on Dynatrace with Andy, and then we thought that the good solution for evaluation of these metrics would be Keptn. And here is a big shout out to Jurgen. He's the guy that spends many hours with me, helping me out. So that's, that's very, very kind of you. Thank you very much. So after, I would say, a month of R&D, different configuration issues, different stuff, different learning curve for me, of course, we were able to come up with some new configuration. We defined a project, a Keptn project, with 3 stages. Those of you who are familiar with Keptn, you know that we have projects, and within the projects we have some stages. In a full version of Keptn, those stages can relate to deployments, to your test stage, prod environment. But my use case was more towards the quality gates examinations. Therefore, I defined a project with 3 stages that reflected no chaos, light chaos, and heavy chaos. And as you might know, if you are familiar with Keptn, you will, or if you are not, at some point you will get familiar with SLIs and SLOs. SLIs are basically the metrics. So these are our indicators, how to measure, how to calculate, and what to calculate in order to tell whether our system behaved properly or improperly. And for me as a QA engineer, and in this kind of situation, there are 2 metrics that are important. First, it's requests per second, the number of requests per second that each endpoint I'm shooting at is able to process. This tells me if I'm basically digesting the traffic slowly or fastly, how it goes. And the second very important metric is total error rate. So total, but by total, I mean that I'm not calculating error rates per endpoint, but I'm only calculating the total error rate. So those are 2 important metrics I use as my SLIs. So I defined requests per second for each endpoint I'm querying, basically, or testing, and I calculate the total error rate for the period of time I was testing. And here you have an example. Excuse my very bad code position at the slide, but this is just an example. This is Prometheus query I used to get the request per second for one of the endpoints. This is basically the rate. Rate is a Prometheus query operator of locust number, locust request number requests. This is the metric exporter from exported from locust. So you can say this is basically the average rate of request for a particular endpoint. The endpoint is hidden here under those 3 dots. And of course, Keptn provides you with some kind of parameterization. Using this duration seconds variable, you can pass during the evaluation of Keptn metrics, you can pass what was the duration of your test. So for me, the metric is parameterized with some duration seconds. When I evaluate my test results, I tell Keptn, hey, please evaluate this particular metric for a time of last 5 minutes or 10 minutes. So the time when the tests were running. And basically this gives me at the very end 1 single number for each SLI. And as I said, in my case, I have 3 endpoints. So these are 3 SLIs, and this is the 4th one. So I will get 4 numbers basically. And for SLOs, this is the important part, I have 2 kinds of SLOs. SLOs are the objectives, service level objectives, service level objectives. So basically, you can tell that each stage of your pipeline, of each stage of your test, can have different SLI results, and then you want to check or ask Keptn to check if the result, if the numbers in the metrics are okay or not. And as I said, told you previously, I treat my stage of no chaos and light chaos as pretty much the same. So for the end user, the number of requests per second should be more or less the same, very close, and the total error rate should be near 0. So in those two situations where we have no chaos and light chaos, there should be barely any difference. I want those states to be similar. So why is that so? Because our application should be resilient, should resist and small variations. If we have some delay on connection between the app and database, it should be okay for the application. It should reconnect, it should wait longer, it should retry, it should not immediately return errors to the user. So the slide chaos is taken so, oh, I'm running almost half an hour. I'm taking a lot of time. I'm gonna go. So to the point. No chaos and light chaos is pretty much the same situation. So I expect the conditions to be the same. And for heavy chaos, I have a bit different conditions, and I will show you how they differ. So the SLOs for no chaos are defined in a file like this. If you are not familiar with the files, that's okay, just take a look at this. So I expect my average RPS for one of the endpoints, so requests per second, to be at least 1.5 requests per second on average. And then the state of this SLO will be passed. But also, if I have at least 1 request per second, so between those two, I will have the status of warning. And then, of course, depending on the status, Keptn provides some calculations, and then they provide you final results. If you want to know more, I sincerely recommend documentation. But for now, let's just say this is our criteria for passing or warning for this SLI. And also for the average fail ratio, I want it in an ideal situation, I want it to be less than 1%. But if it's less than 5%, it's still not so bad. And this is for the stage of no chaos and light chaos. And see that the numbers change for the situation of heavy chaos. So for heavy chaos, I would expect our application to be able to process at least half a request per second per endpoint, or at least 0.2 requests per second per endpoint, because I don't want a total disaster, you know. And also the fail ratio, it should be ideally under 30%, but it's not that bad if it's 50%. So this number changes, but the SLOs are pretty much the same. So how this final pipeline looks like? We have the Gitlab as our runner, and the Gitlab is able to communicate with Locust via API. So I'm triggering my tests, Locust tests, as via API call. Also, I have my Litmus, and I am able to run LitmusChaos engines, so those high latencies or low latencies, so basically introducing light or heavy chaos, via kubectl command. So basically, I'm modifying the deployment in Kubernetes, and I'm activating the chaos this way. I think this is very similar idea to what Jurgen and the team has for integration with Litmus, but I'm yet to discover this land a bit more. But I think we a bit agree on that part. And then as the source of metrics, I have my Prometheus, where I store the metrics or results of Locust tests and the LitmusChaos experiments. And at the very end, I have my Keptn. And at the end of each stage in Gitlab, I'm asking my Keptn, hey Keptn, please evaluate my metrics for each of those stages. And of course, Keptn pulls the metrics or SLIs from Prometheus, and it checks if the SLO is passed or is in status pass, warning, or error, and calculates the final result. So my current state of Gitlab pipeline looks like this. We have, as previously, we have some load tests without chaos, and then I evaluate the stage in Keptn. Then I have some load tests with light chaos, and evaluate the stage, another stage with Keptn, and the same for heavy chaos. So this is not demo, because we don't have too much time for demo, and I really wanted to show you the essence. But let me show you how this looks like in some screenshots. So basically, this is my pipeline, my Gitlab pipeline, where I have the 3 stages defined as separate stages. This is not very complex pipeline. It basically, in each pipeline, I'm only using some curls. I'm only using one kubectl command to activate chaos, and some final evaluation by Keptn. So this is pretty simple pipeline, but it corresponds to think like this. This is Grafana graph, and now it requires some explanation. So as you can see, at some point at night, of course, we have 3 bursts or 3 runs. The green line represents the total RPS. So basically, let's say the RPS, summed RPS of all endpoints, and the red line represents errors seen by Locust. So as you can see, for our first burst without chaos, we don't have pretty much any errors, and we have nice around 2.5 average RPS. Here you can see the second burst. We had some small errors here, but still the overall RPS is very similar. But for the stage of heavy chaos, we are starting to see some errors here. The RPS don't drop too much. Why? Because probably the endpoints are responding with a similar time, but they are throwing errors. So they are throwing timeouts, they are throwing 504s. And very important, and yet very concerning part of this graph is this part here. Because what happens here, we are introducing, let's say our test take 5 minutes. And we are introducing the chaos only for 30 seconds or 1 minute, I think. The chaos engine, the latency has to start here, and then it drops. So we have the error, we should have the errors only here, and then we should not have errors here. And still we see that there are some errors seen by Locust after this. So my guess is that after the experiment is ended, our application is not able to recover on its own. That's why Litmus is restarting pods. And when it's restarting the pods, I'm seeing the errors. So they are not able to respond to me. They are showing timeouts. And this is wrong behavior. I mean, the result of this experiment should be only this errors here, and here I should go to the green area, no errors. And this is very concerning to us because in our first try, in our first experiment, we didn't see that. Now we are seeing that, and there is something clearly wrong. So Keptn is starting to pay off. And just to show you how it looks in a real situation, I don't know if you are familiar with Keptn UI, but here I present you the, do you see my marker? This is the stage of no chaos. And here we have the SLAs. And as you can see, the average RPS for endpoints are around 4. They are not in total agreement with the previous slide, because previously I was calculating average over a different period of time. But anyway, for this period of the test run, we have around 4 requests per second per endpoint, and we don't have any errors. So that's good. And for the light chaos, as you can see, this is very similar. We don't see any errors, and it goes gray or green. There is no problems with that. The result of those 2 tests is pass. But for heavy chaos stage, we see exactly this behavior, this concerning behavior I showed you a moment ago. This test is in status warning. Why? Because the average fail ratio here was over 50%. That means that it's more than I would expect for warning. It's very bad. And it's in agreement of what we've seen in the graph. We should only see a very small part of errors, and then it should recover. It didn't recover. It was still throwing 504s. That's why I see a big average fail ratio. And also one thing that's concerning here is this. These requests per second are only slightly lower than in situation of no chaos. It means that we are throwing errors very fast. And this is concerning. This should not be like this. In heavy chaos, we should have low RPS. The system should try to reconnect, retry, etc. And it should not throw errors all the time. So this is very interesting from the standpoint of analysis. Okay, to the final result. Sorry for being so taking so long. To the final result. The initial goal was achieved. It was achieved by with a strong dedication from our team, with a great help of Keptn team, and I'm happy about the results for now. I was also able to submit 2 pull requests to Keptn community. One was, I think, with some scripting thing, so this was quite funny lesson for me. But the other one was related to a thing we were discovering at some point. And the question was, if we are use the external MongoDB and not the one provided with Keptn deployment, then the answer is yes. You can do it very easily. You need to modify just a few values, and we already discussed how to modify the Keptn code base in order to be able to easily use your own MongoDB instance. On the other side, we tried on 2 versions of
I'm not sure if the network hiccup is on the side of Adrian or if it's on my side. Please let us know in the chat if you can still hear us. Okay, thanks, Michael. So I assume that Adrian will be hopefully back again soon. He also had some network issues earlier today. Anyway, thanks, Adrian. Maybe you can't hear this right now, but thank you so much for this presentation. We are already in the part where you were presenting the results. And I know also some outlook for the future, what actually you wanted to improve. I tried to pull up the slides on my screen and show you the slides. Oh, Adrian. He's coming.
Yeah, so sorry. I think the internet is trying to tell me that I should stop talking. Can you see my screen again?
I was just announcing that you will also be talking a little bit about future improvement. So the stage is again yours.
Sorry, I'm not taking more than 2 minutes. So what's the future? It's not the perfect way in Keptn world. We can develop Locust service, so we can develop a middleware for the Keptn to connect instantly to Locust and to orchestrate everything directly via Keptn. So if we dedicate a bit of time, we can develop an integration between Keptn and Locust, which I think is yet to be done. But there is already existing integration of Litmus, so we can use the Litmus integration, and then we can shift to Keptn as the orchestrator. So we don't need to run the calls manually. We can pass the task to Keptn, and then on our side, we need to improve monitoring graphing, and possibly maybe we can integrate with Argo CD. So the future version of this graph would look like this. The GitLab will only pass some comments to Keptn, and Keptn would be the orchestrator for Locust, for Litmus, and also the evaluation layer. So this diagram would look like this. So we will not have to make all the API calls and kubectl requests on ourselves, but we would use Keptn as the first point of contact. And that's pretty much all. Thank you.
Thanks so much, Adrian, for sharing all of this. I know that we have the Litmus community here, that we have someone from GitLab here. We have a couple of folks from the Keptn community here. So please feel free to share your thoughts. I will allow everyone to unmute. So please feel free to just jump in and ask the questions directly to Adrian. One thing that I discovered while everyone is joining in here is you mentioned that you were quite surprised that the requests during the heavy stage was so fast, or actually that the requests per seconds that they did not drop. So I thought if you want, you could also add an upper and a lower bound in the Keptn quality gate to, for example, get a warning if the requests do not drop. If you expect them to drop, you could do this, so you get the evaluation result. As you're not using it for the complete CI/CD part, but just for quality gates, this is something that was, I was just thinking about this during the presentation.
Very good idea. Very
Others
good idea.
from Keptn here that maybe they want to comment on this. So any thoughts and comments? I see a couple of things in the chat. It was really much appreciated. If you want to also unmute and just join us in the conversation, please feel free to do so.
Hey Jurgen, hi Adrian, this is Karthik from the Litmus team. That was an awesome presentation. Thanks for taking the time to describe the use case and explaining how you went about this. Really interested in, I think, the Litmus service that we are working on. Are there any suggestions you have, Adrian, on how you would like to see Litmus more integrated into Keptn? We were having some discussions around using Litmus for some more use cases than already are being used for.
Yeah, actually, I'm yet. Don't get me wrong. My my development right now was focused on implementing the solution, and now we have the working solution, and now is the time to make the actual R&D. So for now we have, as I said, very simple chaos definitions of these packet drops. We should improve them. I think this is now the time to get into Litmus a bit more, learn about the experiments, learn about the possibilities, and see how our system behave. And also, I'm yet to see the integration with Litmus. So for now, unfortunately, I don't have any advices, but if we can keep in contact, then I will be, Jurgen knows that I like to give suggestions.
Awesome.
So definitely up for, like, I'm really happy to see what's gonna come up with the future.
Great. Yeah, looking forward to that. Thanks.
Yeah, thank you for sharing. Yeah, I think that's a great use case where the Litmus service is used in a real world scenario where we can really learn what is needed. So in the current implementation, we can already basically fulfill the last part or the last image you had where Keptn is doing this orchestration. What's still needed is the Locust service. So if anyone here in this group is working with Locust, has experience with Locust, and wants to join us in building this Locust integration into Keptn, please step up and please get in touch with us. We will be starting quite soon on this implementation. As we've seen, it might be helpful if there are some issues going on that it's basically that we have an integration between the test execution and the orchestration, that we directly know what was actually going on, and we have kind of the bridge as a central hub where we see the information if tests have been executed, what was the result.
Yeah, I think that needs one explanation here, because for those of you who are familiar with Locust, Locust has basically two modes of execution. So first mode is the UI mode, where we deploy our test script or load test script, and we basically run everything from the UI. And the other mode is when we run it. So this UI mode is similar to JMeter UI mode, but with JMeter UI mode, you are using the application. So JMeter application client, whatever. And here you have like website, so standalone website. And the other way to run it is just command line run for a particular time. So these modes are slightly different. So with the UI mode, you have always you are always running the website somewhere on your in your system, and then you can just start test whenever you want, run it, and manually stop it. So manually run it, manually stop it. And with the command line execution, you have, okay, let's run this with 100 users for 5 minutes. And we are using the UI mode. So we have the deployed Locust somewhere. And whenever we want to test performance, we can do it manually. But also, we are querying or starting the tests a bit of a hack way via its API. So basically the same what would UI do. And this is going to be a bit of a challenge for the Locust service to support maybe both versions. But I think we will start working with the UI version and the Locust API. So that's low hanging fruit. Why? Because then if you would like to, if you have this running instance, then you are using the same instance that has the exporter that is exporting metrics. And if you run the command line, you would need to start pods in Kubernetes ad hoc, connect to exporter, and this is more troublesome. That's all.
Got it. Yeah, the devil is always in the details. So it's very interesting to see that there are different approaches to it. Also, the approach we took with integrating the Litmus service to Keptn or developing it, we decided to go for one approach. We've implemented this. It's already out there for everyone in the community to use. And we will be also improving this over the next weeks. So it's always great to see also some more use cases that might be needed. And it's great to see that there's already some demand out there. If there are more questions, please just ask them away. And if not, then I would like to thank everyone. Maybe I just share again my screen just to give you a little bit of background what I'm talking about. So I've put a list of attendees together, the ones that I could see. If you're not fine with having your name out there, just please go ahead and remove it again. That should be totally fine. Thanks, Adrian, for doing this presentation on how you did the implementation, and it was really great to see all these things coming together. We can, if it's fine for you, I would also love to put in the link to the slides in here, so that if someone wants to take a look again and maybe take a look at some of the details, they can do so. I will put the link to the recording. Once it's online, I will put the link to the recording also in here. If there are no more questions, then thanks everyone for joining. We will have the next Keptn community meeting again on the 3rd Tuesday of the month, which will be, and I have to take a look at my mobile. When is the next 3rd Tuesday of the month? And it should be February 16th. So February 16th is our next edition of our Keptn user group. In the meantime, we are hosting our weekly developer calls on Thursday, same time as today. Please also, if you're working with Keptn, if you're more on the developer side, if you want to build integrations on Keptn, please join us on Thursdays. As a last update, we just released Keptn 0.8 in the alpha, as an alpha release. Please give it a try, give us feedback how you like it, give us feedback on the new features, give us feedback if something is not working as expected. It's an alpha release. We do not recommend to already overwrite your stable release of Keptn and use it in production. Please do not do this. But if you have some instances that you are where you're developing with or that you where you're experimenting with, we would really appreciate if you give the new version of Keptn a try and give us feedback on this. You can reach us Slack or on Twitter, Google Group, on all the channels that you already know. So thanks everyone. Thanks Adrian, and have a great rest of your day. Usually after these kind of events, we would go for a beer. I'm really sorry. We have to. Oh, very good. It's not the Puntigammer, but
it's my green water bottle. So
it's a water bottle. Okay, I thought it's.
Unfortunately, I still need to. I still need to drive, but the next beer I have, I promise to make a salute.
Great. So thanks everyone. Hopefully see you all again next time.
Thank you very much, guys. I appreciate your time and your recognition, so to say. Have a great evening.
Thanks everyone. Bye.